And I'm going to take some questions from the homeworks. Caden. Number 7. Come on. All right, 7. Caden, what did you get for part A? We're probably going to need some of your answers there to do C. Good, that's correct. For part B, okay. And then we have AH and AG. Okay. So I'm going to start with looking at AG. So there's my calculation triangle for AGF. You good with that, Caden? Okay. So GF is 2 because it's the same as BA. And I can find AF. Well, we did it already. It's 5.83. So I can calculate AG then just using the Pythagorean theorem. And I get 616. We happy there? Now I got to do AH. So I'm going to do that where this is a midpoint. Is that okay? Oh, I guess we called this point K. We put that in there already. My apologies. So that's also a right triangle. And we know AK is 522. And we told that H is 4.5 meters above the ground. So HK is 4.5. Is that okay, Caden? Okay. So then I can do my Pythagorean theorem on that. And here I get AH is 689. So which one is longer? AH is longer by 0.73 meters. And I just did the subtraction there to get the 0.73. Does that feel okay, Caden? Okay. You're welcome. Ingy.
Whoa, that was a crazy one.
Is number 4 like the bowl one? Is this the one? Or this one? Okay. Can we stop talking and pay a bit more attention? Trevor, close your eyes. Whoever took his pencil, put it back on his desk. No. You're welcome. All right. Excuse me, guys. Number 4 says we have a hemispherical bowl with a radius of 15. Some liquid has been poured into the bowl to a height of 8 centimeters with a circular surface of radius BC. State the length of AC. Okay, that should be easy. Notice that A is the center of the hemisphere. So AC is a radius. So that's just 15. Okay with that, Ingrid? Similarly, we know that this is also a radius. So if this is 8, that piece has to be 7. Okay with that? And then we can just do the Pythagorean theorem to find out BC. So when I do that, I get 13.26, or sorry, 27. Is that okay there? So the trick there was identifying all those radii inside of that hemisphere. And if you noticed what was a radii and what wasn't, it was pretty easy. If you missed, that those two things were radii, you would have stared at that for a long time going, I don't think there's enough information, probably, right? Yes, Meg?
I know 7.
Well, the radius is 15, and we're told the water's at a height of 8. So 15 minus 8 is 7. See, we're told that right there. Drew. 41.6. Sure. Okay. So this is a radius. So it's 22. This is a radius. So it's 22. So the calculation triangle that I'm going to make is right here. So that side is x. So h is just going to be x plus 22. So I can just use the Pythagorean theorem to find x. Right. So I go from the bottom to here is 22, and then here to here is the x. That's the top of the water. The height of the liquid is h.
Why would it be plus 22?
So starting at the bottom to here is 22, and no problem. You cool with that? Yeah. So this one over here is tricky to see. Again, if you have a sphere or a hemisphere, there's lots of good potential radii you can draw in that can be very useful. I think almost all of them, yeah. In fact, I think actually all of them.
Yeah.
You should have used a calculation triangle at some point. Olivia. Sure. All right. This is 14. So calculate the lengths of ME and MF, which are the same. So, okay, so I'm first going to draw a calculation triangle to do that. I guess I will do like MCF. So FC is 60. And MC we can calculate because we know that MB is 40 and BC is 50. So I can just use the Pythagorean theorem to find MC. Olivia, are you okay with that? Yeah. Okay. So that gives me, MF as 87.75. We happy there? Okay. And then it says calculate the value of angle EMF. So I'm going to use the blue calculation triangle that they've drawn in. Notice, though, that that calculation triangle they've drawn in is not a right triangle. That's okay, but if I have a non-right triangle, I have to use the law of sines or cosines. Now, in this case, I know the length for ME, and I know the length for MF, and I know the length for EF. Since it's a side-side-side situation, I'm going to use the law of cosines. So I would say that EF squared is equal to ME squared plus MF squared minus 2ME times MF times cosine of angle M. So M is going to equal the cosine inverse of EF squared minus ME squared minus MF squared over negative 2 times ME times MF. And that's what I'm going to type into my calculator then. And that'll come out to be 54.24. Is that okay, Olivia? Good. So, again, like, we preferably would like to have a right triangle, but you're not limited to one. In particular, in a situation like this where we can draw an isosceles triangle as our calculation triangle, that's pretty good because really we only have to find one side to that, and then we could use our law of sines or cosines to knock out that angle measure. So I think that happens another 1 or 2 times in this problem set where you could use the law of cosines to kind of solve for that angle measure a little bit quicker than trying to do it with all right triangles. And you could have done this using all right triangles, but it's kind of a pain. Not a mega pain, but like more of a pain. You're welcome, of course. And you're happy with like not filling the numbers in with, okay. I figure if you're looking at notes later on, that might even be easier than the numbers. Jacob, what's up? Oh, okay. Yeah, you don't have to apologize for stretching. Again, 12.
Or just like angle law.
Okay.
I don't know if that's
So I'll ask for your other answers for those other parts.
okay.
And as long as they're right, I have the answers in front of me, so I'll
I put AD was
58.31.
and angle.
That seems unlikely.
Yeah, let's just not go.
Okay.
That's too bad.
All right. So
Yes, it is.
all right. Do you want to do this with right triangles or without right triangles? With? Okay. So we are told that C is the midpoint. So those guys are 30, right? So here's my plan, is X is going to equal angle DAB minus angle CAB. Take a look at that and tell me if that makes sense.
Yeah.
Everybody agrees with that? The advantage there is that DAB is a right triangle. So I can find that pretty easy. And similarly, CAB is also a right triangle. So I can find that pretty easily. So we have the tan inverse of 60 over 40. And then we have the tan inverse of 30 over 40. So when I take 56.31 and subtract it from the previous, I get 19.44. For X. Are you happy with that, Meg? Okay. Now my plan for Y is going to be 180 minus X minus angle ADB. Okay with that? That's just using a triangle inequality.
You use like the angle C and then just subtract it by 180.
Yep, you could do that also. Not really decidedly different than what we're doing right here. But that'll work because the angle ADB is just this one right here.
Yeah.
So this is just 90 minus 56.31. So that's going to just give me 126.87. Okay with that, Megan? Okay. Again, you could have done these using like law of sines or cosines and non-right triangles. It was possible to do it that way also, but you didn't need to. This is, I think, pretty straightforward, just using right triangles. It's not too bad. But you could have used the non-right triangle way also.
You have found like ADC and then ACB.
So you're talking ADC is this angle. That's what we found here, right? I just called it ADB, but it's still the same angle. And which other one?
Like for your calculation, you have done ADC and ACB.
Well, ACB is what we have here. And you said which other one? ADC is not a right triangle. You can still use it, but you have to use the law of sines or cosines on it, which again, not the end of the world, but you know, maybe a little bit less obvious of how you're going to use it.
Yeah, I did that, but I made it wrong.
That would be why it was wrong.
Yeah.
Okay. Meg, you happy now?
Yeah. So, and can you just repeat the answer to number 6?
Number 6 was 41.6. You're welcome. Who else has some from this homework? I can take a couple more before we move on if you guys still have questions on things. If you don't, that's okay too. I think you asked about the hardest ones, so that's good. Okay. If everybody feels good, we'll move on to the notes here. So this is our last section in chapter 9. It is a quick chapter. Yeah.
That's Monday. No, it's over. The other class is Friday. We get the weekend study. Oh, I'm not going to complain. Thank you.
Okay. So today we're going to finish up chapter 9 talking about, stop talking please, calculating surface areas and volumes. So some common surface area and volume formulas are these. Okay. Do I expect you to memorize these? No. I'm going to give these to you. What do I expect you to be able to know?
How to use them.
Yeah, what the letters represent and then kind of how to use them. Okay? So let's just talk through what these letters represent here real quick. V is volume. So in a cuboid, that's like a box, what is L, W, and H? Length, width, height. Okay, that should be good. For a right pyramid, volume equals 1/3 capital BH. What is capital B?
Base.
Not quite.
Area of the base.
Area of the base. Very good.
Oh, it's lowercase base and like apostrophe is in.
Yes. So the surface area formula, area of the base plus T1, T2, T3, T4, etc. What are these T's representing? What are these T's representing? So the figure is a right pyramid. The T's are the area of the triangular faces. So in the case that the base is a square, all those triangular faces are the same, right? But if the base is not regular, you know, if it was like a rectangle or something, some of these areas of these triangles would be different. Everybody okay with that idea? But that's what the T is, just the area of a triangular face. Cone, 1/3 pi r squared h. What's r and h? Radius and height. What is this curly L here? It's not length, not specific. It's the slant height. So the edge of the cone, that diagonal edge of the cone, that length is the slant height. Everybody's okay there? Or the slant length, whatever you want to call that. But that's what that thing is. Sphere. What is the R?
Radius.
Radius. Hemisphere. What is the R?
Radius.
Radius. What do you notice the relationship between a sphere and a hemisphere is with the volumes? It's half. Right? Half of 4/3 is 2/3. Half of 4 pi r squared is 2 pi r squared. What do we mean with when I have no base and with base?
If it has a base, then you have to use 3. If there's nothing on the bottom, you use 4.
Good. So like you guys have like, stop talking please. Like a cupcake topper, like the thing that you put like your cupcakes under with the glass top. Right? You guys know what I'm talking about?
Yes.
That's like a hemisphere with no base because it's open. Right? So like, you know, in the exercise room, that like half of a ball thing that sits on the ground, that's like a hemisphere with a base where it's closed.
It's like a cupcake top. We'll have like tray cupcakes and have
It's like an upside down bowl.
it's like a lid.
Yeah. Everybody okay there? Okay, so you'll have to pay attention to the context of the story problem to decide which one of these two situations you're worried about, right? Whether we have to worry about a base or not. A right prism, again, capital B is area of the base. What do you think this R1, R2, R3, R4, etc. is? Good, it's the area of the rectangular faces. Very good. If the base is a regular figure, like a square, all those rectangles will be the same. But if that base is not regular, like it's a rectangle or something, where all the sides aren't the same, the rectangles would not be the same, right? Not all of them. Everybody's okay there? And then cylinder, same idea, right? Everybody feel good about these formulas and what the letters represent? So let's do some example problems then. So first one, we have 3 tennis balls. Stop talking, please. Packed into a cylinder container, just touching the sides, top, and bottom of the container. So they're wedged in there basically as tight as they'll go. The diameter of each tennis ball is 6.7. We want to first write down the internal height of the container and the diameter of the container. What's the height of the container going to be? How many tennis balls tall is the container? 3. How tall is each tennis ball? 6.7. So how tall is the container? 3 times 6.7. Okay. How wide is the container? Yeah. The same as the tennis ball, 6.7. Everybody feel happy there? Hopefully that makes sense, right? Caden should be well familiar with this as he plays tennis. I've seen tennis balls packed into a container. All right. Next up, we ask for the volume of the container. That's pretty easy, right? The volume for a cylinder is just pi r squared h. So what is the 3.35? Yeah, it's half of the diameter. So half of 6.7, which is the radius. Everybody happy with that? That's pretty easy. Okay. It says the curved surface of the cylinder is made of plastic, and the tops and bottoms of the container are made of metal. Calculate the area of the plastic used. So I'm going to use the surface area formula for a cylinder without the 2 base on it. So if I went back and looked at that surface area for a cylinder, we have the no base version. That's what I'm using there. To get 43 or 423 and change. Is everybody okay with that? And then if I want the amount of metal used, that's just the top and bottom. So that's the 2b, right? So 2 pi r squared, which gives me that 70.51-ish. Pretty easy, right? Not bad, right? We're just filling in some formulas, using a little bit of common sense about spatial reasoning or whatever. Well, it's touching. To get it out, it would probably need to be a little bit smaller, but the friction on the side is going to be pretty low, so it probably still could slide out even if it is touching. All right. Next up, the base of a prism is a regular hexagon with sides of 3.5 centimeters. The length of the prism is 19 centimeters. Calculate the volume of the prism. So here's our picture. Notice here when we talk about the height, stop talking. When we talk about the height of a prism, we're not talking about a vertical distance necessarily. We're talking about the distance from one base to the other. So the height for this prism is the distance between the two hexagons, no matter how you've laid that prism. Everybody's okay with that idea? Okay. So to calculate the volume for the prism, that's area of the base times the height. So how do I calculate the area of a regular hexagon? What does regular mean? All the sides are the same length and all the internal angles have the same measure. Everybody's good with that? So how am I going to calculate the area of that thing? I'm going to divide it up into 6 triangles. Okay. So what kind of triangles have I made here? Isosceles, very good. So what is this apex angle for this isosceles, for one of these isosceles triangles got to be? 60. Fantastic. How did you get that? Excellent. One full rotation is 360 degrees. I divided that among 6 triangles. So each of these apex angles is 60 degrees. So really, I don't have an isosceles triangle here. I have something even better. It's equilateral. If the apex angle is 60 and the 2 base angles have to be the same because it's isosceles, those have to be 60 also, so it can add up to 180, and I have an equilateral triangle. Everybody good with that? How am I going to calculate the area of this then? I'm not going to use 1/2 base times height. We have another area formula for a triangle. We talked about it earlier this semester. 1/2 AB times sine C. That's what I'm going to use here. So the area for one of these triangles is like 5.3-ish. So what's the area for the hexagon going to be? 6 times that. Everybody's good there? And then the volume for the prism is going to be 19 times that, giving me 604 and change. Is everybody okay there? Now I want to make a point here of mentioning, in this chapter, I'm going to be quite picky about your units on the test or whatever. So make sure if you're giving me a volume, you have units cubed. If it's an area, it's units squared. If it's a length, it's just the unit. I'm going to be picky about that, so I want to make sure I'm mentioning this now. So make sure you're careful about your units. I am going to be picky about that. Okay. Everybody good on this one? Okay. Part B says that I'm going to turn this prism into a pencil case where I'm going to actually need the area of the material to make each one of these cases. That's the same thing as surface area, right? Everybody's good with that idea? So for my surface area, how many rectangles do I have here? 6 of them, right? That look like this. How many hexagons do I have? 2. So my surface area is going to be 2 times the area of the hexagon plus 6 of these rectangles. I know these rectangles are all the same because this is a regular figure. Thanks, Hanukkah. Is everybody okay there? So we know the area for the hexagon. We already figured that out in the previous part. And the area for the rectangle is really easy. It's just length times width or base times height or whatever you want to call that. So when we do 2 times the base and 6 times the rectangle, we get 462 and change. Everybody good with that idea? Next, I don't remember if there's one more after this or not. It's either the last or second to last one again. All right. A lampshade is made from a cone of glass with a glass hemisphere as its base. The slant height of the cone is 29 centimeters and the diameter hemisphere is 11 centimeters. Calculate the surface area of the lampshade. So if I want the surface area of the lampshade, it's going to be, is that going to include the base of this cone? No. Is it going to include the base of this hemisphere? No, because the lampshade is this cone on top of this hemisphere, right? So neither one of those two things are surfaces. Everybody agree with that? Okay. So I'm going to take the surface, or just the area of the cone without the base, which is just pi RL, and just the area of the hemisphere without its base, which is 2 pi r squared. And we have everything we need there, right? The radius is 5.5, half of the diameter, and the lateral, or the lateral length, or the slant length, or what, I forget what the term is. Anyways, L is 29. And we add those two up, and we get 691 and change. Everybody happy with that? That's the area, the surface area. What? That's the surface area. Yep. Okay. The next thing we want is the volume. So similarly, I'm just going to find the volume of the cone plus the volume of the hemisphere. So there's my two formulas. So I know R, that's 5.5, but I don't know the height, right? The height of the cone. I can find it though, right? Pythagorean Theorem. So that height is 28 and change. So my volume for the cone in the volume of my hemisphere, I can now compute. And when I add them up, I get the volume for the lampshade. Is everybody okay with that idea? Worth pointing out that I like to put the subscripts on like problems like this where I have a couple of different shapes that I'm worried about. where I'll type, like I'll write volume of cone and volume of hemisphere, because it just helps me keep track of what I'm doing. I encourage you guys to kind of do the same thing. It helps at least keeping track of your work when you're doing a problem where you have like the volume of several figures that you're kind of working with, or the surface area of several figures. Okay? And Megan, this was the last example, just FYI. So we'll stop here.